Hello to the familiar faces in the participants list. Nice to see you.
So hello everyone. Well, welcome to today's seminar. As we get ready to start, maybe you can share in the chat where you're joining us from. It's always interesting to see who we reach and how far our reach is with these seminars. While you do that, a bit of housekeeping. Please be reminded that this seminar is recorded and that the recording will be available on the SEB Vimeo page within a day or so. And you can, of course, also access all of our previous seminars in the Emerging Issues in Conservation seminar series on the SEB Vimeo page. So I would like to request that you please keep your microphones muted and your cameras off for the duration of the seminar. At the end of the seminar, there will be opportunity for questions and discussion. And at that stage, you're welcome to unmute, switch on your video, and engage with our presenter today. You're, of course, welcome to also post comments and questions in the chat, and then we can also deal with those questions at the end of the seminar. So with that, welcome to what is now our 25th seminar for 2021 in the Society for Conservation Biology's Emerging Issues in Conservation seminar series. In the series, we feature articles selected by the editors that are recently accepted in early online view or recently published in the 3 SEB journals, those being Conservation Biology, Conservation Letters, and Conservation Science and Practice. Please visit the Emerging Issues in Conservation seminar webpage to see a list of our upcoming seminars through August and September. So my name is Martin Strauss, and I will be hosting this seminar today. I'm a senior lecturer in the Department of Environmental Science at the University of South Africa. And I'm also an associate editor at Conservation Science and Practice, and it is in that capacity that I've been organizing the seminar series to date in 2021. Now, it is my great pleasure to introduce you today to Dr. Molly Grace. Now, Molly Grace is a research fellow in conservation biology at the University of Oxford, Department of Zoology, and a teaching fellow at Wadham College, Oxford. She co-chairs the Green Status of Species Working Group of the International Union of Conservation of Nature, IUCN, and the Green Status, a new part of the Red List of Threatened Species, assesses species recovery and conservation impact. Molly's research, therefore, focuses on developing and refining a scientifically defensible yet practical definition of recovery, which involves research on species ecological functions and historical baselines. Now, Molly received a PhD in conservation biology at the University of Central Florida in the United States, her native country. And today, Molly presents on their recent paper in the Journal of Conservation Biology, which is currently available online in early view, entitled Testing a Global Standard for Quantifying Species Recovery and Assessing Conservation Impact. And with that, Molly, over to you.
Thank you very much for that introduction. And it's really, really wonderful to be here today. Thank you all of you for joining, including some colleagues and friends and collaborators that I see in the audience. It's very nice to see you here. And thank you very much to SEB for inviting me to take part in this seminar series about emerging issues in conservation. So as you know, my name is Molly Grace. I did a PhD in conservation at UCF. And I see some of my UCF colleagues in the audience as well. Very nice to see you all. But currently, for the past 4 years, have been based at the University of Oxford in the UK. And I've been undertaking a knowledge exchange fellowship there. Now, I'll give more details on what exactly that means in a minute. But the work that I'm going to present today is the culmination of that knowledge exchange fellowship. I also co-chair, as Willem said, a working group for IUCN about the green status of species. And if we look at the title of the paper that I was asked to present on today, Testing a Global Standard for Quantifying Species Recovery and Assessing Conservation Impact, spoiler alert, that global standard is the IUCN Green Status of Species. So I've just read out again the title of the paper that we published just a few weeks ago in Conservation Biology. However, you might have heard of this paper referred to in a slightly different way. As in, oh yeah, that paper that was published in Conservation Biology with over 200 authors. And I would like to take a moment right now at the beginning of the talk to thank each and every one of the co-authors whose names are scrolling past on the screen in front of you right now. Some of them are in the audience right now as well. because without each and every one of them, this paper would not have been possible. This was not an exercise of giving authorship away unmerited. But even so, you might still be wondering, Molly, how did it come to this? How did you end up leading a paper with over 200 authors on it? And the short answer is knowledge exchange. So I mentioned that I've been in Oxford for the past few years as a knowledge exchange fellow. I've been funded by the Natural Environmental Research Council here in the UK. NERC. And so NERC knowledge exchange fellowships are given to academics like me who want to work with non-academic stakeholders to produce research that has high impact. So in my previous life, before this fellowship, I was primarily a pure ecologist. I called myself an applied ecologist. I did work that could potentially have impacts for conservation, but I wasn't really engaging with stakeholders that much. I would sort of publish a paper and say, yes, I've had some impact from my research. But with this knowledge exchange fellowship that I'm on now, my non-academic partner organization, which is the IUCN, gave me a problem to solve, which is, guaranteed impact from the work that you're going to do. And I found over the years that producing truly impactful research takes a lot of people and it takes a lot of time. In fact, this project started back in 2012, before I was even involved, when the IUCN passed a resolution calling for the creation of a green list of species. So what this means is that the IUCN's global membership voted that the world needed some way to measure species conservation success. And this would be called the green list of species. So some of you might be a little bit perplexed at the moment because the IUCN is very well known for its red list of threatened species, which measures extinction risk. We already have one colored list in IUCN, why do we need another? So for the past, since the 1960s, the red list has been our premier way to measure conservation success, which looks like a species moving from a higher risk extinction risk category, like critically endangered, down through endangered, vulnerable, and eventually, hopefully, least concern, which means we have a species that is not at risk of going extinct in the foreseeable future, or the near future at least. So if we already have this globally recognized tool for measuring conservation success, why would we need another one? Why would we need a green list? Well, recently people have started grumbling and starting to wonder, in terms of conservation success, as a measure of success, is avoiding extinction alone enough? And to think through why people have been thinking this way, let's quickly review how the red list looks at extinction risk of species. So we know that extinction risk increases when a population gets very small. And we also know that a declining population has a higher risk of extinction. So let's say we have a hypothetical species where each of these dots represents 5,000 individuals. And let's say the population starts to shrink, it starts to decline. There is some threat acting on this population, causing it to become smaller. So the extinction risk of this population has gone up. And it continues to decline, our extinction risk continues to increase and increase. But let's say that at some point the population stabilizes, the threat is removed, and so we've just stabilized at this lower level. And let's say that this population is still big enough that it doesn't qualify as a quote unquote small population, one that would inherently be at risk of extinction because of various demographic or stochastic processes. So eventually, in this scenario, the red list status of this species would become least concern. Because the threat driving the extinction risk of this species is no longer operating. And of course, we should be happy, and we can be happy that the extinction risk for this species has been removed, and removing the threat is definitely an achievement. But when we think about how much of this species we've lost, how many areas of this species are grayed out now, and how many potentially systems we've lost this species from, can we really call this a conservation success? Or now should we be thinking about how can we recover this species and its ecological functions to the systems from which it's been lost? So while without really thinking about it, we might think that recovery is just the inverse or the opposite of extinction risk. We really should be thinking about them existing along two parallel axes. So on our extinction risk axis, we have the red list categories. And then we can have underneath it a hypothetical recovery axis ranging from 0 to 100%, where 100% represents a fully recovered species, whatever that means. We haven't defined it yet. So conceptually, it's quite easy to see how a species that is extinct or extinct in the wild would map to the lower end of our recovery axis. So it would be, 0% recovery for an extinct species. The interesting scientific question that we didn't have an answer to at the beginning of this project is, where do least concern species fall along this recovery axis? And based on that hypothetical population I've just shown you, it really could be anywhere. We don't know. Is there a one-to-one link between least concern status and the recovery status of species? What it comes down to is that extinction is something that we want to avoid. And for decades, we have had a tool to measure progress towards avoiding that thing that we want to avoid. We've had the red list. But recovery is something we want to achieve. And we haven't had a way to think about that conceptually or measure it until recently. So the IUCN called for the creation of a green list of species to fill this gap. So in addition to knowing the extinction risk of a species, we also want to know how close to recovery is the species and how close can we get in the future. So after that 2012 resolution, a task force was established. And over the next few years, this task force conducted global consultations to ask the scientific and conservation community, what is recovery? What do we mean by it? And then once we all agree on that, how do we measure it in a robust yet user-friendly way? I've just got a notification that my internet connection is unstable. I apologize if I go in and out, and maybe Martin, you can let me know if it gets really bad. But yes, we formed this task force. And the task force has over 20 members, but it has been led by a core team whose faces you see on the screen here, representing academic institutions and NGOs and the IUCN itself. And these people have been absolutely amazing colleagues and partners in this work. So I would have to give a thank you to them as well. So after years of global consultations, in 2018, our task force published a framework for how a green list of species would work. And this paper was led by my colleague Rezat Aksakaya at Stony Brook University in the US. And this framework paper was published in Conservation Biology, Quantifying Species Recovery and Conservation Success to Develop an IUCN Green List of Species. You'll notice that the author list is much shorter for this paper than the one that I'm presenting on today. But the purpose of this framework paper was to explain the basic ideas of the method. So what is recovery and how do we measure it? And invite feedback from the scientific community and the conservation community. And in our framework paper, we describe the two main aims of the green list of species. First, to measure species recovery, and second, to assess the impact of and incentivize conservation action. So I'm going to spend a little time focusing on how we proposed to measure species recovery. So in our 2018 framework paper, we provided this definition of a fully recovered species. We consider a species fully recovered if it is viable and ecologically functional in each part of its indigenous range. Now, I know there's a lot to unpack in this definition. I promise I will go through each of these terms and explain them more fully as we go throughout the talk. You might also notice that I've omitted a few words in between indigenous and range. That's mainly for clarity and to make sure that I stay within time on this talk. However, it's a great opportunity for me to mention that what I'm going to be describing today is a very high-level overview of how our framework for measuring recovery works. And if you're really interested, I encourage you to read the papers for the full story. So we have our definition of a fully recovered species, and now we have this y-axis showing a species recovery score ranging from 0 to 100%. So if a species met this definition of a fully recovered species, it would be given a species recovery score of 100% under our framework. And if the species was extinct or extinct in the wild, it would get a 0. However, of course, most species are going to fall somewhere in between. And just like in the red list, to aid in communication of these concepts for the general public, and let's face it, even scientists like having things that are easy to understand, you can also translate the species recovery score into various categories. So at the top, 100%, we have a fully recovered or non-depleted species. Moving down the categories through slightly depleted, moderately depleted, largely depleted, critically depleted, and then finally 0% is extinct in the wild. And the dream, the goal, is that one day we'll have two parallel categories that we could use to talk about species conservation. So we have our red list extinction risk category and our green status recovery category. So we might say, rather than, oh, this species is least concern, in the future, we might say, oh, here's a species that is least concern, largely depleted, adding that bit of information into the species conservation status. Might be wondering, that's lovely, Molly, but how do you calculate this magic number, this species recovery score? So let's go back to that definition. I'm going to break down each of these undefined terms and define them and talk about how they contribute to the calculation of a species recovery score. So again, we consider a species fully recovered if it is viable and ecologically functional in each part of its indigenous range. Let's first talk about indigenous range. What do we mean by that? So the indigenous range is the known or inferred pre-impact distribution of the species, pre-human impact. So at the time when humans started significantly impacting the abundance and distribution of a species, where was the species found at that point in time? And this point in time is going to vary, of course, from species to species because the timing of human impacts and the sensitivity of species to human impacts varies. It's important to note that the indigenous range is often much larger than the current range of the species. So I've used the Javan rhino here as an example. You can see on the map, there's light green denoting the historic distribution, equivalent in this case to the indigenous range of the Javan rhino. But if we look at where the species is currently found, it's found in that tiny green speck in the bottom of the screen, which I've circled because it's quite hard to see. But if we were doing a green list recovery assessment for this species, we would be considering all of its indigenous range in the assessment, not just the tiny speck where it's found now. Going back to our definition, what do we mean by different parts of the indigenous range? Well, in our species recovery framework, once the indigenous range has been identified, we ask assessors to break it down into parts called spatial units. And the idea of incorporating spatial units into a recovery definition is because we want to capture variation that exists across the range, and we want to incentivize recovery across all parts of the range. When we say variation, this could be variation in status of the species. In some species, some parts of the range are doing very well, some parts are doing very poorly. In some places, the species has been entirely extirpated. But variation can also mean biological or ecological or genetic variation in the species as well. And are we thinking about all those different aspects of variation in our conservation of species? So when we did a preliminary assessment of the leatherback turtle in collaboration with the IUCN Marine Turtle Specialist Group, they chose spatial units based on genetics. So each of these colored blobs represents a genetically distinct part of the leatherback population. So those were the spatial units that they chose. Going back to our definition, if we want a species to be fully recovered, it must be viable in each of these parts of the range, in each of these spatial units. This is pretty straightforward. A viable species is simply one that's not in danger of going extinct. And so we just follow the red list's lead on that. We use their criteria to assess whether a spatial unit is in a threatened category or not. And this was important to us to include because the first goal of conservation is and should be preventing species extinctions. So a recovery definition has to ensure that we are also working to prevent extinction in the species. And finally, a fully recovered species is ecologically functional in each part of its range. And conceptually, I think this is probably the most complex part of the recovery definition that we laid out in our framework. Because species don't exist in a vacuum. species interact with other species, they interact with the abiotic environment, and they perform a lot of ecosystem functions that are important to us and to the biosphere in general. And so we wanted to include this and make sure it was represented in our recovery definition. And so an ecologically functional species is one that exhibits a full range of ecological interactions, functions, and other roles in the ecosystem. That is easy to say. In practice, as I'm sure you can imagine, it can be more difficult to do. Some species have very obvious ecological functions, apex predators, for example, that are strongly interacting. And so I'm sure many of us are familiar with the classic example of the trophic cascade. When you get too few otters in a system, urchins become overabundant, and that leads to an unfavorable ecosystem state. But not all species have such strong functions. Not all of them have such obvious functions. And I don't have time today to talk about how we recommend measuring function for the purposes of a recovery assessment, but Reza Daksakaya led another paper, also published in Conservation Biology, called Assessing Ecological Function in the Context of Species Recovery. And in that paper, we lay out a framework for measuring recovery. In brief, a spatial unit could be considered functional if we observe the function. So, if we have a species like the otter, where we know that if we get below a certain number or a certain density, we're going to see some dysfunction happening. We could also have a spatial unit be functional if we're not observing dysfunction, so kind of a elimination approach rather than a confirmation approach. And then finally, we give some proxies as well that can signify function. But if you're interested, I recommend that you read that paper. So to recap the process of this recovery assessment, the first step is to define the species' indigenous range. Next, define that range into parts, spatial units, and then assess the state in each of those units. So we've talked about what it means for a species to be viable or functional in a spatial unit, and those are the statuses that we want. However, if a species doesn't meet the criteria for either of those, it could be considered present instead. Or if a species has been extirpated in a spatial unit, it would be considered absent. And then we can take that information about the state in each spatial unit and convert it into a green score, or a percent fully recovered. And you can think of this sort of, it's not a perfect analogy, but as kind of a weighted average across the different spatial units. So to calculate the green score, or G, first we look at the state in each of our spatial units, and you can see in the table that each state is given a weight. Absent has the lowest weight, functional has the highest weight. And so in the numerator of our calculation, we're just summing the weights of all of the states of the spatial units in our indigenous range. And then the denominator is simply the functional weight times the total number of spatial units, regardless of their state, regardless of how they're doing. And then multiply that times 100. What this means is that if a species is functional in every single one of its spatial units, it would get a green score, G, of 100%. It would be considered a fully recovered species. And if a species is absent in all of the spatial units, it would be considered extinct in the wild and have a score of 0%. And of course, most species are going to fall somewhere in between. So you'll remember that before I talked about a species recovery score. This is the special name that we give to the green score at the time of the assessment. So the current status of the species is the species recovery score. And that can be also translated into a species recovery category for easier communication. So if an assessor wanted to, they could simply stop here. They've assessed the current status of the species, they've generated a species recovery score and a species recovery category. They could stop the assessment there if they wanted to. However, the other primary aim of the Green List framework was to assess the impact of and incentivize conservation action. And so rather than simply assessing the green score at the current time, giving you a species recovery score, you could also think about what would the green score today be if no conservation action had taken place in the past. And the difference between the green score generated under that scenario and the actual observed green score gives us a metric that we call conservation legacy. This is a really useful metric because I think in conservation, we often feel like we're running really fast to stay in the same place. So conservation progress can take a long time. But if we hadn't done the actions that we had done, the status could in fact be a lot worse. So this gives us a way to measure that. We could also think forward into the future and say in 10 years' time, based on the conservation actions that are going on currently and that are planned within that time frame, what do we expect the green score to be in 10 years? This is useful for donors and people working on the ground to sort of think about what can we actually expect? What is a realistic outcome for the work that we are doing over this time frame? And that's, that metric is called conservation gain. We can also think of the inverse, and we can think about in 10 years' time, if we stopped all conservation today, what would happen to the species? This gives us a metric called conservation dependence. And this is a useful metric when we think about justifying continuing conservation action, which can sometimes be expensive, or people might not realize the need for it. And then finally, one of my favorite metrics is recovery potential. So this metric asks us to think, in 100 years' time, in the next century, if everything went right, if we had all the funding that we needed, if we had political support, based on the areas of the world that have been irreversibly converted for human uses, what is the maximum recovery we could biologically get for this species if everything went right? And you will notice that it's not at 100%. For many species, it's not going to reach 100% because some things have irreversibly been changed in the world. But this metric gives us a way to think about, you know, if humans really got their act together and we had all the resources in place, what is possible for this species, which is really useful in conservation planning. Now, you might be thinking, how on earth could I know what the impact of past conservation has been? How can I project what's going to happen in the future? And that's a very valid question, which I don't have time to answer today. But we did publish a paper this year in Biological Conservation about building counterfactuals and scenarios to evaluate conservation impact. And so it's sort of a step-by-step guide for doing this in a robust and defensible way. And we reference back to this species recovery framework and how it can apply in that scenario. So I recommend that you check that out if you're interested. So that was a very brief overview of the recovery framework that we published in 2018. And so once we published this framework and put it out into the world, we needed to test it. And we needed to see, does it work for every species? Do we need to tweak it? Does it work for flora, fauna, fungi? And so between 2018 and 2020, I've been working with people who volunteered their time to take a species they knew really well through the green list assessment method. And in the end, I worked with over 200 collaborators from 38 countries, thanks to those of you who are on the call. And as you've just heard, these assessments can take a bit of time to wrap your head around. So every one of these people was undertaking a complex and rigorous process to generate these data. And testing the framework would not have been possible without the expertise and the time volunteered by all of these people. So I thought it was only right that they deserved to be authors on any papers that came out as a result. And that brings me to today. So to the publication of our paper in conservation biology with 204 co-authors who worked to test this framework. Here it is in all its glory. The author list has been abridged, but the eagle-eyed among you might notice something. And that is that the article impact statement references a green status of species and not a green list of species, which is what I've been talking about this entire time. There's a long story behind the name change, but all you need to know is that between 2018 and 2021, it was decided by IUCN that green status was a better name than green list. But it's exactly the same thing. Everything that I've been talking about up to this point still applies. In fact, if you go to IUCN's website, you will see information about the green status, not the green list. I encourage you to check out this website if you're interested. It has more information about the recovery assessment, and it has links to materials to get involved and actually do one of these assessments if you are so inclined. So I'll put this link up on the acknowledgement slide as well. So what were the findings of this paper that we published a few weeks ago? In the end, we were able to test the green status of species recovery framework on 181 species. We tried to sample across terrestrial, freshwater, and marine species, but as you can see, there was a bias towards terrestrial species. In the end, we were asking people to volunteer their time and expertise, so we sort of had to take what we could get in terms of the distribution of species that we assessed. However, this paper was really more about showing that you could apply a recovery framework and that it would work for all these different species, rather than actually making, analyses of recovery across different taxa or different groups of species. So it's definitely not a representative sample. I look forward to doing that sometime in the future. We tested across the tree of life, well, at least macroscopic eukaryotic life. So the size of the pie slices represent the number of species in each of these groups. And again, we could talk about the representativeness of this group of species, but at the end of the day, we were just happy that we didn't only test on mammals and birds, which can sometimes happen in these big conservation studies. And finally, we tested species from across all the different red list categories of extinction risk. And this was really important to us because we wanted to see if having the green status actually adds information on top of what the red list shows us, or is it simply redundant? And are we asking people to do a decent amount of work for no real benefit? And we were happy to find that the answer to that question was no. So here on this figure on the x-axis, we have the red list extinction risk categories. As you move to the right, you have a higher risk of extinction. And then on our y-axis, we have our species recovery score from 0 to 100%. So of our tested species, we did find that the species recovery score was correlated with red list category. So species at higher risk of extinction tend to have lower species recovery scores. However, this was by no means a perfect pattern. In fact, we observed species across all 5 of these different extinction risk categories that had the exact same or very similar species recovery score. So we can take the example of the Antiguan racer, this lovely charismatic snake, which has a species recovery score of 57%, putting it in the moderately depleted category and the green status. On the red list, it is critically endangered. So this species has a lot of ongoing threats. Sea level rise threatens the amount of habitat available for this species. Invasive predators are a huge problem. So critically endangered is certainly the right extinction risk category for this species. However, with the exact same species recovery score of 57%, we have this Candilia mangrove, which is least concern on the red list. The threats have primarily abated. It was heavily logged in the past, but that threat is no longer in place and the species is recovering pretty quickly. So here we have 2 species, one that's in the very worst possible red list category and one that is in the best possible red list category, and yet they have the exact same score on the green status. So in terms of their indigenous range, the proportion of their range that is viable and functional, they're doing the same. And then we can have cases where the green list the red list and the green status work together to tell a more full conservation story for a species. So pictured here is the burrowing bettong, or booty is another common name. I think I prefer booty. And it is an Australian marsupial. It is near threatened on the red list. So that's a pretty good status. We generally think that near threatened species are doing okay in terms of extinction risk. And it's actually improved its red list status over the years. It used to be critically endangered, but due to concerted conservation action, it is now only near threatened. However, it has a species recovery score of just 17%, which puts it in the critically depleted green status category. And this is because this species used to range all throughout Australia, but currently only exists on a few offshore islands and tiny pockets of the mainland. So having the green status category alongside the red list category allows us to celebrate the success that we've had in reducing the extinction risk of the species. But it reminds us that the species has a long way to go towards recovery and that we still have work to do. And so what about the green status's second aim, which is to assess conservation impact? Well, we assessed each of the 4 conservation impact metrics. I mentioned them briefly, but again, they're conservation legacy, conservation dependence, conservation gain, and recovery potential. We assessed each of these for all of our 181 species, and these are the results displayed by red list category. What was interesting to me is that when we look at sort of the trends across red list category, extinction risk was not really a predictor of conservation impact for conservation legacy, dependence, or gain. So sort of thinking about the past impact of conservation and the impact of conservation in the short-term future over the next 10 years. Which is interesting because we might think that species that are more at risk might have benefited more or have more conservation attention, but we didn't find that to be the case. There was a positive trend looking at recovery potential. This is probably because species that are at high risk of extinction tended to have a really low species recovery score. So they had sort of more room to grow. If you're at the bottom, the only way you can go is up. So they did have higher recovery potential. But it's encouraging that even for these threatened species, experts assess that recovery could still be biologically possible if humans get their act together. And then looking at the general impact of conservation in our data set, there were only 3 species that didn't show any conservation impact across all 4 of these metrics. And there were only 14 that had enough uncertainty that we couldn't say for sure if conservation had had any impact on these species, which means that in our data set, 91% of species showed past or expected future impact of conservation, which I think is a big cause for optimism. So I'm reaching the end of my time, so I'm going to leave you with a few take-home messages about the green status of species. As I've said multiple times, the green status has 2 aims, which is to measure recovery and to measure conservation impact. And I'm also happy to say that the green status is a new part of the red list assessment process. So rather than being in competition with the red list or something separate from it, IUCN has endorsed the green status will become a new part of red list assessments. So they'll be able to be displayed together and show the full conservation story for a species. Another take-home message, I hope I've convinced you that recovery is not simply the inverse or opposite of extinction risk. You can have a species that is doing very well in terms of extinction risk that is very far from recovery, and vice versa. And finally, the green status of species is not just a list of recovered species. Any species, no matter how close or far to recovery, can be assessed using the green status methods. So what is next for the green status of species? The IUCN standard document was published in July. You can see the lovely cover of that document on this screen. And this is simply the IUCN's formal documentation of the method that I've just been describing to you today. So you can peruse that and learn a bit more about how this method works. The preliminary assessments of the 181 species that I mentioned for this paper, we hope to finalize and publish on the Red List website in December. There's going to be an update of the Red List then. We're developing online training, an online training course so that more people can be exposed to the method and learn about species recovery and how to do these assessments, because our really big goal is, of course, to do more assessments of species recovery. So if you find this interesting, or if you think your organization would be interested in carrying out some assessments for species that you care about, then I'm very happy for you to get in contact with me. I would love that to happen. With that, I would like to thank you all for your attention. Of course, I have to thank a lot of people, in particular the Green Status of Species Task Force and my co-chair, Barney Long, also Liz Bennett, who co-chaired before me. And of course, a number of partners and donor organizations, including NERC and IUCN. So thanks very much, and I'm very happy to take any questions.
Thank you very much, Molly. That was a very interesting presentation. while people kind of get their thoughts aligned to ask you some questions, you may be interested to know that we've got participants from a far field as Zambia, Namibia, Mozambique, Sweden, the US, Germany, and of course the UK too. So quite good representation today. So there are a couple of questions in the chat, but maybe before we go to the chat, is there anybody with a burning question who would like to unmute and maybe ask Molly? Otherwise, I will read questions from the chat.
Martin, is it best that I keep sharing my screen or take it down?
You can take it down. Yeah. No takers? Okay, let's go to one of the questions from Claudia Schuner from Germany. And she was wondering, do you score the indigenous range also regarding its current suitability as habitat for the species in concern?
Well, okay, so I think there's two ways to answer that question. One is that I think what you're getting at is that some of the indigenous range might no longer be suitable for species to occupy. So parts of it might be a parking lot or a shopping mall or something. There's no way we're ever going to recover a species to that point. That's true. The point of determining indigenous range is to sort of provide a benchmark that can be compared across species, but also give us a way to recognize how much has been lost due to human activity. So even if we can't recover the species to all of its indigenous range, the fact that it's lost some of that range is showing the human impact that's happened for that species. So we don't want to choose a less ambitious indigenous range because that would sort of let humans off the hook for the changes that we have wrought in various species. But we also, of course, when we're thinking about recovery, want to think about, what can we do for the species? So the recovery potential is kind of a more accurate reflection of what parts of the range are still available for species to potentially reoccupy. And I didn't talk about it in this talk, but we also consider the impacts of climate change and will the range of the species change and will we need to think about new areas in terms of recovery. So I didn't have time to talk about that today, but that is included in the framework.
Okay, because that was a question that I had with regards to recovery potential. Is if you think about climate change and ecosystem change and potential new ranges, whether all of that is incorporated. So you say it is in there. It
is, yes. Yeah, I don't know how much detail people would want me to go into.
Paper, do we?
Sorry?
We need to go and read the other papers, do we?
Yes, let's say that. But it is incorporated.
Okay, cool. There's a hand up by Riley Pollum. Riley, do you want to unmute and go for it?
Hi, Riley.
Hi, Molly. Excellent work, excellent presentation. My question to you is, and I say this sort of biting my nails as a Red List coordinator who looks over about 300 species. There are over 130,000 species on the Red List. You guys have got through 180 so far. So what's the plan moving forward to? And I know the Red List hopes to even up that number in the next couple of years. So what's the IUCN's plan? What's your plan for ramping this up across species?
Great question. It's going to be slow to start, but the goal is to get someone in the Red List unit to work specifically on coordinating green status assessment. So we have that sort of formal support and generate a lot more donor funding to be able to pay people to work on this. Because we know, as anyone who's familiar with IUCN or even conservation projects in general, is often there's not enough money and not enough people. So we want to get some money to get some people working on this, or else it's going to be hard. Volunteer work can get you very far, but we'll need some funding to do it.
Thank you.
Maybe linked to that question, what is the anticipated assessment interval for the green status?
Do you mean how often would a species be reassessed?
Yeah.
I think we're going to follow the Red List's lead on this, which is about every 10 years, 5 to 10 years. Our working group is thinking about that question though, because there might need to be a different interval because this assessment is different, but we expect it'll be around the same time.
Okay. There's then a question in the chat from Gustav Samilius. Would it be of interest to do the evaluation of green status between areas for a species to get an idea of where the most imminent conservation need exists for that particular species?
Very good question. So we are trying to figure out how do we take this global assessment and adapt it to be a regional assessment. So the red list, you can assess a species at the global level or at the regional or national level, which is a very useful feature. And I think you're right, Gustav, that it would be great to be able to compare recovery between different parts of the species range. So we are working on how can we adapt this to be regional or national, but we need some postdocs and students to work on it, I think.
Thank you. There's also another question from Claudia Schuner. Can you measure how the recovery of one selected species might impact on any other species of the same habitat?
That's a fascinating question that I would love to study. I expect that, maybe in 10, 20 years time, when we have lots of green status assessments, there's going to be such fascinating studies that one can do about functional interactions and recovery status sort of just globally. In terms of the impact of one species on another, what I can tell you now is that there are some cases where a species could be considered dysfunctional in part of its range, if it's perhaps overabundant and negatively affecting another species. That's sort of where the thinking's at right now. But again, this is sort of very early on in the framework development. And I think over the next decade, we're going to see lots of interesting sort of addendums and new applications of this.
Thank you. Question from Christopher. Is there any quantitative measure of how accurate green status assessors are at estimating conservation impact? Or is this something that will be tracked in future?
Hi, Chris. Great question. This is something that we have thought long and hard about, because obviously for many species, we don't have sort of controlled data collection or for impact evaluation of conservation actions. So there is a lot of reliance on expert opinion, as in many sort of areas of impact evaluation. So I mentioned in the talk that we've published a paper in Biological Conservation that provides sort of a framework for assessing conservation impact from inferential data. And what we try and do in this paper is sort of account for all the possible sources of uncertainty and propose ways to reduce them. So we talk about, people clearly establishing what their frame of reference is, what variables they're including, what is the impact they're assigning to each one, and also, other methods that you can use to sort of narrow in on a more accurate prediction. So getting more people involved, doing something like a Delphi method. So you're right that there's a bit of uncertainty in expert opinion, but there are ways that we can work to reduce that uncertainty, or at least document the assumptions that have been made, and someone can come back and challenge that later. Oh, sorry, Martin, I think you're muted.
My apologies. There's one more question in the chat from Claudia Schuner, and that was related to the definition of fully recovered. And she was wondering to what extent you think that is a realistic definition, or whether one shouldn't come up with a more realistic definition if you're considering the whole range or previous range, indigenous range.
It's a great question, and it's a philosophical one that has to do with, do we look at this definition as sort of an assessment tool, a scientific measure, or as a goal? And I'm very much in the camp that this is literally just a scientific assessment. Full recovery would be wonderful for species. By the definition that we've provided, for many species, you're right, Claudia, that it's not going to be achievable. So I think there is a balance of recognizing that this is supposed to be a standardized assessment that looks at the impact that humans have had, how much have we depleted a particular species. And so that this assessment will tell us that. Will it tell us what our goal for conservation should be? Not necessarily. It can definitely help inform it, but there are so many different factors that go into determining what a conservation goal or aim for a species is, that this is really only one piece of the puzzle.
I have another question from Gustav Semelius. Maybe you mentioned it and I missed it, but can the green score go over 100 for an invasive species?
No, it cannot. So if, well, I guess there's two ways you could think about it. So an invasive species has obviously expanded its range past its indigenous range, but we use IUCN definitions of what sort of the native range of a species is. And so a species that has an invasive part of its range, we just don't really consider that in the assessment. Yeah, so it can't go over 100%.
Another one from Claudia. Claudia, do you want to unmute and ask Molly?
Yeah, I can. Sorry, I have a very unstable internet connection here on this stormy island. Thanks for the exciting talk. I was just wondering if it's always just human beings who might have depleted habitats. I mean, if we look at all the fires going on or the flood catastrophe that we just had some weeks ago, or volcanic eruptions, that would also sort of destroy certain habitats, probably. Yeah.
Yeah, absolutely. And so I think I've been a bit lazy in my terminology, sort of saying, yes, humans have done this. In many cases we have, but you're right, there are other things that could reduce the available habitat for a species. I mean, a volcanic eruption for sure. I guess when we think about floods and other weather catastrophes, we could blame humans for some of those too. But you're right that there are more dimensions than just direct human impact to think about here, and that are considered in this framework.
Okay, right. Thanks very much.
Molly, in the paper, you indicate that for almost half of the 181 species tested, I think for 48% of them, conservation legacy was indeterminate or zero. Now, that should probably be a concern. I know it wasn't a systematic survey, but do you kind of, is another spin-off of this that these assessments would help flag where things are simply not working and those people can kind of reassess what needs to be done potentially to try and make an impact?
Yeah, definitely. So you've clearly read my paper very thoroughly. I appreciate that. So he was saying that for many of the species, nearly half, there was no conservation legacy, or it was too uncertain for us to actually say what the legacy of conservation had been. For many of those species, that was because no conservation action had been taken. For those where it was, we did sort of identify, we followed up with the assessors and asked, why do you think this was? And there was a number of questions from, the intervention wasn't planned properly, or, we lost funding halfway through, or it wasn't appropriate for the species, or even the scale of the green status assessment wasn't at the right scale to actually measure the impact that had happened. Because when you think about it, the green status is actually quite a coarse measure. So if we haven't had enough conservation impact to move from present to viable in a spatial unit, we're not going to see that impact reflected, even though the spatial unit might be doing a little bit better. So yeah, this is one tool that could potentially flag where, thinking more about the conservation interventions that have been used as needed, but because of issues of scale, I would also say it shouldn't be the only tool that's used.
Okay. Then we have another question in the chat from Philip Magnon. How far back in time do you currently go in terms of defining indigenous? Asking as a paleontologist. And do you think there's scope for incorporating fossil data?
Do you want to collaborate with me, Philip? This is where I want to go next. So the cap on how far back we can go in time is the year 1500. And the simple answer for that is that that's the earliest year that the red list considers species. So if a species was not extant at 1500, it can't be assessed using the red list criteria. And so we've sort of carried that over into our framework. So 1500, that's a little bit more recent than directly using fossil data. However, I think there is a lot of scope for using fossil data as, sort of a base for where the species was at earlier points in time. It can be used to inform species distribution models that can inform what the indigenous range is, what the future range could be. So this is something that I'm really interested in looking into.
Really interesting question, Philip. Would you like to respond to that?
Sure. No, that sounds great, actually. I'll actually drop you an email about it if that sounds good, because it's something I'm really interested in as well. So
that would be great. Thank you.
Cool.
Okay, there are no other questions in the chat, so you are welcome to either put your hand up or simply unmute and fire away with your question.
Shall I just put my email in the chat if anyone would like to contact me? You're very welcome to.
Well, I was really glad to see the kind of indigenous range as the baseline, because locally here with regional assessments, I've kind of flagged previously that that the whole shifting baseline scenario and that we're not necessarily sort of measuring things correctly. How big a problem is that globally?
Ooh. So I haven't delved into this aspect of the work too much. I have been talking to some historical ecologists and paleoecologists in the course of doing this work. And I think the overall conclusion is that neo-ecologists like myself really don't think about the past enough. But there is lots of data out there. And so I'm hopeful that in the next decades, we'll see sort of a bit more unification of the different timescales in ecology, because I think we definitely have a lot to learn from the past. But yeah, I think it's not being considered nearly enough.
Thank you. Is there anybody with maybe a last burning question for Molly as we get close to our time limit? I think I've handled all the questions in the chat, Molly. Couple of comments thanking you for a great presentation. Very informative. Great work. Keep it going.
Thank you all for your great questions.
So unless there's perhaps a last question, Molly, I would like to thank you again for the time and effort that you put into preparing for this. I know it's not a matter of just showing up and doing the presentation, so thank you. And thank you for your willingness to participate. It was a great talk. Thank you.
Thank you so much for the invitation. It's been really fun.
And then thank you also to the audience. We've had some great questions, and please visit the Emerging Issues in Conservation webpage to see a list of our upcoming seminars. We don't have one scheduled for next week. That's unfortunately been cancelled, but we will reschedule that one. But otherwise, I hope to see at least some of you back in our future seminars. So thank you very much. And with that, goodbye.
Thanks, everybody.
That was great, Molly. Thank you very much.
No, thanks.